share this out to other people. There we go. Okay. All right. Ready to go. Go for it.
Well, today we're going to talk about a highly problematic thing when you're dealing with DevOps or systems in general, and even applications. I was talking with Noah earlier, and one of the things that that especially happens in books is that a lot of technical books specifically, they go in and jump directly at like, say for example, logging, which is what I want to talk about today. This is how you set up logging, and off you go. But sometimes it's useful to understand why is this thing important. Like, okay, yeah, sure, you're showing me how to do this, but why? What problem are we solving? What are we trying to do here? What are these things important, and why do I need to learn them? And logging specifically in Python is pretty tricky to get right. The logging library it can be very daunting. It has lots of knobs and things. It actually has like multiple ways to configure. You can actually configure with a Python dictionary and slap a Python dictionary onto this object, and off you go. It's already configured. So there's a lot of like, okay, so logging is complicated. So a lot of people avoid logging and say, like, just send everything to standard out or standard error if that's what you want to do. And it's an afterthought. But so that's the idea. That's what I thought would be useful to give a primer on logging. And in the Python for DevOps book that we both wrote, we had a bunch of stories, and I think that was good to give people context. Like, yeah, this is logging. This is how you configure it in Python. But like, what's the deal here? And we did a bunch of other things. It wasn't just logging in Python. There was, I think we did a little bit of Prometheus and Kibana. Like, we did the Elk stack, which is Logstash, Kibana, and Elasticsearch. So a lot of that. So like, why would you ever want to use these things? And probably Noah, you have stories on your end. But like, I'll tell just one, pretty short. And I think this one is in the book. I was working as a software engineer in this large media company, and we were working in this large platform that hosted many different web services and actually websites, but some services around that website. And it had one main or primary database and like 2 or 3 secondary ones or backup databases. And the performance team, which I was part of, had progressively identified that this situation was getting progressively worse every day between 4:30 in the morning and 6:30 in the morning. Like, the whole database would just start getting worse and worse, and these spikes in memory and CPU were getting worse. Like every other month, like, it would just get worse and worse. So it was progressively getting worse. So they say, you need to go investigate this and find what's going on, what's the deal with it. So I went in, and I'm like, first thing I asked for is like, hey, so I need some logs. Can you send me the logs? I was asking the DBAs, send me the logs of the databases, and they were like, no, we can't do that. I can't give you any logs. And it's like, what do you mean you can't give me any logs? Like, how can I just look at what's going on if you don't give me the logs? And they said, well, we can't enable the logs because whenever we're enabling the logs, the system just the whole server just comes to a stop. Like, it just doesn't. You're almost basically bringing the main production database to a crawl, to a stop, and in a non-working condition. And that to me was, yeah, I've never heard anything like it before. And I guess to some extent that makes sense. So we made a compromise where the DBA would wake up at 4:30 in the morning, enable it for 15 minutes, and then get me those logs for 15 minutes, that time span, and then I would just go in and try to find out what the deal is. And what ended happening was that with those logs, I could actually see the queries, the expensive queries. Like there's a PostgreSQL actually is pretty useful for this. It has a way where you can say, where you can explain queries, and you can spit out the logs in such a way that you can then ingest those and say, tell me what are the most frequent queries and the most expensive ones, and sort them out. And I actually wrote a small Python tool to just grab those and compute like what the deal is. And what ended up happening was that there was a select all, and from like all of the items on all of the tables, and which is doing very expensive copies. And spend some time trying to look into the application code, like where was this? Because sometimes when you're using an ORM, things get abstracted. And so when they get abstracted, you're not seeing raw queries anywhere. You're getting, just Python code everywhere. So look for it everywhere, and couldn't find it. And so like I was running out of ideas, and then I asked permission to get into the production database server, and I got in. I was like, so something felt suspicious here, because it's happening consistently early in the morning, and it's progressively getting worse. What is going on here? Like something like, is this something that gets scheduled for whatever reason? So I decided to look into the cron tab, and lo and behold, there was a script like 4:30 in the morning, or 4:31 or 4:30. This like just it would run every day. So it's like, what is in this script? And the script was doing the select all and doing the copy. And so I asked, like, what's the deal with this? And they said, well, we're backing up the database. And that was the one problem with it. Like, it was just every day it was doing the select all, dumping everything to a SQL file, and then just basically saving that file. But I mean, there are other ways to create a backup, and this was certainly not one way to do it. And the system already had three secondary databases, so they were already replicating almost in real time. So your backup was already there. It was one of any of the three databases was the backup. You're having replication in real time or almost real time. You don't need to select everything. But so the gist of the story, or the whole lesson learned here, is that logs are very powerful, and you probably are not entirely sure when to use them, or why would you need them at all, until like you really need them. And then you're like, oh man, like I really need logs. I really need to know what's going on. And yeah, so that's that. It's just one of these things that, as you have more experience, you start learning that there might be situations like that, and logs are going to save you, especially when logs are good. But you probably also have good stories about logs, Noah.
Yeah, I can think of some similar things. Like, I remember something like you just described. I was working at a major TV studio, actually, and there was somebody that wanted me to set up a directory server, so like an LDAP directory server. And we use that to do NFS mounts of home directories, which is, people don't do that anymore, but at the time it was really helpful, because you could go to any machine in the company and you get your home directory, and you get like your configuration to write code and everything. And it was working well, except for the fact that it kept having periodic lockups. Like there would be some problem with it. And I knew there was nothing I had done incorrectly. And one of the things that happened was that I did something similar. I actually basically wrote my own monitoring system, where I looked at network traffic, DNS queries, like all kinds of things, and I just wrote out all the data, that anything that could affect the network, the server, and I just started dumping it out to a file every single minute, right? So I basically wrote my own kind of monitoring system from scratch. These things didn't really exist back then. And then I plotted it into Excel, and then I realized something similar. I was like, ooh,
Excel.
once a week, somebody was doing some kind of query automatically against the DNS server, and it locked up every computer in the whole company. And then it made it look like the service that I set up was messed up. Yeah. And so people were, yelling at me like, "Oh, you didn't set this up right," all this. And it turned out that just somebody was just being an idiot. They were basically taking the whole DNS server and just locking it up. And then all these machines behaved, but it was only once a week. And so I think a couple of things I learned from that is that, yeah, if you don't have monitoring, you're going to be in trouble. And then two, that you do have to have like a time series based approach where you look at what's normal and then what's abnormal. And that's really like a statistical technique, which is and I could I'll just draw this real quick. So this is something I can just share real quick. Let's do this, and let's go to Sketch, and I will share.
Also, you know what? Similar to what you're setting up, that sounds similar to sports as well. Like when you're doing really like any kind of like competitive sports, or at any, like you're competing and doing a bunch of stuff, you need to keep track of what you're doing, what your performance is, because otherwise, like the next season comes around, and how do you know if you're improving or you're going backwards? Like, say if you're doing push-ups and like, oh, this season I did 10 push-ups every day. It's like, oh, okay, great. Next season comes around, it's like, you're gonna do 20 push-ups or 25. Like, how does that work? And keeping track and knowing what your baseline is, it allows you to make adjustments.
Yeah, this is kind of interesting. We'll just keep this in the middle of us. So this is a normal distribution, and all this means is that this is the real world. Like, things that are normal fit this bell-shaped pattern. So it means that, like height is a bell-shaped distribution. I hope I spelled that right. Weight, lots of things, eruptions in Yosemite, like lots of things hit this like normal distribution. And in the middle here would be the median. So like when someone says that the median height, I don't know, let's just say it's 5'9", that's the median, then you can, there's rules that apply. So like the rules are that a standard deviation is how much difference is there between each of these segments. So we can say, maybe this is, one standard deviation away is 5'7", and then 2 is like 5'5", and then 3 is like, I don't know, 5'3" or something like this. And what this means is that when you're basically to the left or to the right, so -3 standard deviations or +3 standard deviations, that 98 or 99%, let's just call it 99%, I think, if I remember correctly, of all observations will occur within 3 standard deviations to the left or the right, which makes sense, right? Like, you don't see like a ton of like, 3'4" people, right? Like that's a very rare occurrence, right? And likewise, you don't see like if someone was here and they're 3 feet tall and 4 inches tall, that's abnormal. Likewise, you also don't see people that are like 8'9", right? Like these are very abnormal occurrences. They're not impossible, but they're really unlikely to have occurred. And so this is the basic, really the foundation of something called 6 sigma. And what 6 sigma is is it's a way of coming up with quality control. So you say, look, I kind of understand the world, the server, and so instead of height and weight, you say the server is more than likely to be, we'll say at the worst, it could be 800 milliseconds. That would be the worst. Typically, it could respond. But in the best case scenario, maybe it can respond in 50 milliseconds, right? And so when you go through here and you build out a world like this, and you get something that's abnormal, like, what? 7 seconds. What this means is that this is a defect, right? And so this is really when someone says, hey, Six Sigma, I'm Six Sigma certified, it just means that you understand probability distributions and that you can build quality control mechanisms around that. So essentially, that if something that's an outlier appears, there's something unusual happening. Like the world as you see it has changed. And so in this particular situation, a server, like if a server is responding very quickly, like it responds in 1 millisecond or it responds in like 30 seconds, there's something wrong. Like you need to check it. And so I think that's a very important concept with monitoring and logging, is that if you're not keeping track and you can't plot a normal distribution, and then you, first of all, like you said, you don't know what's the baseline. But once you understand what the baseline is, you can plot things and if something's wrong. And like you can do the same thing with housing prices, right? You can say, if the median home price in the US is 200,000 and then there's a home price for 2 billion, is that likely that that's true? Maybe, but the odds are very low. It's like,
Right?
It would be extremely rare. Like, and likewise, if there's a home that's like 50 cents, is it true? Maybe, but probably very unlikely. And so if your API was serving out, home price predictions or home price records or something, and then you get it returns something that's that far out off from the median, like more than 3 standard deviations away, then like, there's something wrong. So I think that's the core intuition behind logging and monitoring that isn't talked about that much, but is extremely important. And in fact, I actually used this one time when we were trying to figure out. I was at another company, and this was a virtual reality company that was in San Francisco, and let's just say they made 1 million a month in profit, which I think is about right at the time. And all of a sudden, it dropped, and they were making, let's say, 750,000 a month for like 2 months, and we're like, that's weird. And the last 36 months, they made 1 million. And then all of a sudden, they made 750,000. There's something wrong. And at first, people were like, oh, the sign up is all messed up. The sign up form, somebody changed a button, it's the button's fault and all this stuff. And people were just kind of, chasing their tail, all this stuff. And I was like, this is weird. This is interesting. Let me think about it from a statistical standpoint. So I looked at the servers, the login server logs, and what I was noticing as I plotted everything again, I plotted this distribution right here, and you could see that the amount of responses for people requesting logins was typically, let's just say, 80,000 logins, per day. And then all of a sudden it was like totally, it was like a big, it was like dropped dramatically. And I was like, what's different? And then as I dug into it, it turned out that there was, let's say, 4 servers here. Is that one of the servers, as I dug into it, was not working. It was offline. It appeared to be up. The network cable was like unplugged or something. And so basically it was just dropping traffic silently. So everything looked like it was working. And so the only way you can figure out something like that is by, well, one way to do it is statistically, it's impossible for in a normal distribution for there to be that big of a change unless the world has changed. But in this case, the world did change, which was so that's just a good intuition is once you understand the normal distribution, you realize that if something's 3 standard deviations away from the median to left or right, like it doesn't make sense. So it's not possible that like, oh, well, we're just getting less traffic or like, no, what happened was something changed. Someone moved the cheese and the wrap went somewhere else in the maze.
Yeah, that's really powerful. And I'm gonna take I'm gonna tell another story here, but like it's actually very similar to what you mentioned. It was this was another company, and I was getting excited about Graphite and Statsd. So Graphite is a time series. It has a lot of things. It's a web interface. It's an API. It has a time series database. But basically, you send stats to it, and these can be counters. These can be time-based packets, and it plots everything. And you can do comparisons. You can say, hey, I want to look at a year ago and how I was, and like just don't collect all of don't save all of my data. Start trimming away. Get averages. If you were talking about 10 years ago, like you probably don't mind that much. But so that wasn't implemented, and I wanted to get it in, and so I got the chance to try and convince all of the managers, because like it was kind of like a big project, and there was like a bunch of pushback, and they were like, we already have logging, we already have metrics. Our ops team is like very advanced, has all of these monitors. So we know RAM, CPU, disk usage. We control everything. So I did a presentation, and my I opened by asking these questions, like, but are we really monitoring? And the responses were like, yeah, ops team, big screens, we have RAM usage, like it looks great, requests per second, the web server is doing great. And so I dug in a little bit into it, and I said, well, or make deeper questions. And I said, well, okay, so let's assume we just like, I click a button and we have a release right now, like the website, the new version is out. And the web server looks fine, memory usage great, load balancer seeing requests come in, and it seems to me that, and I open up the production website and I circle around on the corner and say, it seems to me that this button over there, that's a pretty important button. Like that's when you go and buy a subscription and then you become a customer. And everybody's like, oh yeah. What metric do we have? What tracking system do we have? In what graph should I look if suddenly the JavaScript is broken for the current release and the web server is fine, but everybody clicks on the button and nothing happens? Like what do we have to identify a problem like that? And the answer, of course, it was like, oh, nobody knows, because that kind of metric doesn't exist. So how can you instrument? And that's the key thing, right? It's the instrumentation, like what allows you to start gathering metrics on things that you think are important, like a sign up button, and send metrics to another place that's going to capture these and it's going to tell you a bunch of information. And if you can, all the stuff that you said just reminded me of that thing where like my example is like, well, what if like we're receiving 100 requests every minute and then all of a sudden that drops to 0? You're going to be like, whoa, like red flag, we need to roll back. But otherwise, you're not gonna catch it. So I ended up implementing Statsd. Well, I think Statsd is not that commonly used these days, but and the way it works, the way Graphite receives metrics is over TCP. Mm-hmm. So it's blocking, and Statsd is interesting because it's a service that you run, and then it buffers all of the metrics. So you're sending, and allows you, it can receive over UDP. So your application is non-blocking. sending counters and sending all kinds of metrics. Because the worst thing would be to like, hey, I crashed my application because it was trying to send metrics. Yeah, don't do it. So it was, and then Statsd just grabs all of the metrics, buffers them for whatever setting you have, and then just dispatches those metrics and those numbers off to the Graphite instance, basically making sure that everything gets captured. But it's a pretty interesting model to do. But like, yeah, all of that stuff made me reminded me of that.
Yeah, the other, maybe the last thing I can share too is one more thing, which is that the other thing I see with people do with logging is that they, and for some reason in particular, this is like something I see a lot of people do is something called NIHS. Does anyone know what that stands for? It stands for not invented here syndrome, right?
I was going to say not invented here, but like the S threw me off, and it's like I don't want to I don't want to mess it up.
And this is you've seen this for a long time in logging, where someone is like, let's say there's a commercial service, and we can talk about some of them, like Splunk is one, Datadog, Sumo Logic, all kinds of these services. And what's interesting about this is that there are people who are very dangerous in a company, and I call them the knob fiddlers. And the knob fiddlers, they want to fiddle knobs, and unfortunately, the knob fiddlers want to build a bad version of Splunk or a bad version, of Datadog, and then this is your logging solution, and it applies to other things too. I would even say maybe even it applies to like deep learning and machine learning, and like if there's a higher level solution, and then you're just building this yourself because you just want to have fun and you want to tinker around in your company, this can really bite you, because what happens is, let's say you got lucky and you made it better than Datadog or something like that. Well, what would happen? And I guess I could spotlight this so people can see the here we go. Let's see, spotlight. I think I go here, and then I can do this. There we go. So like what's a problem though with this is that even if you did, and you wouldn't make one better than that because you're just one person, what happens when you leave? Then you just totally messed over your company, and then now someone has to maintain your project. And what's going to happen the day you leave? They'll delete it. Like literally, they're like, "Oh, I never liked that anyway." Boom, it's deleted. So I think that's another thing too, is like work on the right thing. Not like rebuild a logging solution or monitoring solution that's crappy yourself. Just use like, open source software, or use a commercial service, or use something that somebody else is focusing on, so you can build the stuff that matters in your company. That's one other thing I would just maybe is like in closing.
And that's a good recommendation. And in addition to that, I would mention that sometimes people say, yeah, well, okay, yeah, let's reuse these. There's this famous library over here, but it doesn't do quite what I want, and like I don't like this portion of the API. I wish it could be a little bit different. Let me fork it, make the changes in GitHub, and now like you're a maintainer. Like, no, don't do that. Do not do that. And then issues don't bubble up back to the originating project. So like whenever I've been in environments where that happens, it's like, look, I get it. We need to go fast. This is the fastest way to get what you want. I would ask you two things. Go make an issue in the parent project and say, we need these. These are the changes. Like you already made the changes, because like if you fork the project, you make a copy in your own repository and you're making the changes, consuming the changes, like it already does what you want. So get those changes back to the upstream repository, because what's going to happen when there's a vulnerability in that project that gets patched, but you're not keeping track of that because you're a fork project. Like nobody's reporting vulnerabilities back to you. You're a copy. So
Yeah,
just be mindful when
is a
you.
dangerous thing. Ego, and I think that's a lot of it is like hubris and ego is a very, very dangerous thing in a software company.
You
Great.
need to
Yeah.
identify it and get rid of it.
Yeah. Well, it looks like we were able to talk about a lot of fun stuff,
Yeah,
and I
this is
think
great.
anything else you have to add, or
No, I think that's great. I think having a conversation about why things are important is pretty useful. And I really like what we did in the books where we were telling stories about giving people context. Not
Mhm.
only, hey, Splunk, this is how you use it. Elasticsearch, here you go, some settings. Off you go. Here's some nice graphs. Have a good day. That's not the thing, right? We're coming with these topics because they're important. We know they're important. We've gone through the experience of having these issues, and we solve them by implementing the services. And I think that's great. And yeah, no, that was it. And it's great to talk about all of this good stuff.
All right, we'll see you next Thursday. See everybody later.